now I will explain what is the reason for this jitter. So suppose this yellow line is the timeline for your process frames, and this green line is the timeline for your physics frames. So let's assume that the velocity of your object is moving at 1. So in the physics frames, the position of the object will be updated by x is equal to 1 every physics frame. Okay, let's suppose. So this is the first physics frame. So here the position will be 0. In this second physics frame, here the position will be 1. So in the here it will be 2, 3, 4, 5, 6, 7, 8. Okay. So but you will be seeing the object through the process frames, because this is where the system monitor refresh rate, or the visuals refresh here. So in this first process frame, your object will be seen at 0. In the second process frame, your object will still be seen at 0 because the physics frame hasn't updated, the process frame has updated. So it will be 0. Here it will also will be 0. So here it will be 1 because your physics has been updated. The one physics frame has passed. So here it will be 2. Here it will also be 2 because again the physics frame hasn't been updated from 2 yet. So here it will be 3, and here it will be 4. Here it will be 4. It will be 5, 6, 6, 7, 8. Okay. So as you can see if you see through the process frames, you will see that the physics is seems to be updating inconsistently. Okay. Because you can see it is 0 for 2 frames, it is again 1, and it is again 2 for 2 frames, it is 3, then again it is 4 for 2 frames, it is 5, again 6. So you will feel that the body is moving unusually. So this will what you will see as jitter. Okay. So how to fix that? The one way is to fix that, the move that this physics body, whatever your body is in the process frames. But that will not be a ideal solution, because physics frames, the difference between the times when the physics frame passes are a constant. We keep it constant because to give ideal physics simulation to the user, the gamer who is playing the game, and this is constant in the physics frame. This delta, the time between the two physics frames, but delta between the two process frames depends on the speed of the monitor and other stuff also. So this is not constant. Okay. So now the other option is that whatever is visible, we will move that in the physics frame, process frame, sorry, not physics frame, and we'll let the physics bodies move in the physics frame. But it is a little bit tricky, because uh, the the things which are visible to the users are meshes. Usually the meshes are the child of physics objects, and physics objects are moving in this physics frame timeline. So now the first thing we'll do is that disconnect the the meshes from the physics objects, and we'll move the meshes in the process frames with respect to the physics objects. So let me tell you some more things. So whatever you see in the screen in the Godot, I'm talking about Godot, uh, is actually already passed, and you are seeing the history. The actual calculation is going somewhere here, but you might be seeing this frame. Okay, so keeping this in mind, the Godot will expose some variable, this physics interpolation variable. Uh, we'll see the exact name of this variable in after some time. So what this variable does, that it will give you this ratio. Suppose you are in this process frame, it will give you this ratio. If you if you project it to this timeline, it will give the value of x upon y. So it will give you the latest time difference between the latest physics frame which has passed and the upon delta of the physics. So it will give you the value of x upon y. So for this process frame, it will give you the value of this one, x1 upon y1. So it will give you the value of y1 is this, the time difference between third and fourth physics frame. So for this one, it will give you x1 upon y1. For this process frame, it will give you the value of x2, and this time difference will suppose this is y2, x2 upon y2. So you can see that this time difference will be uh, same always. At least we try to keep it same. This y1 and y2, because this is the physics frame timeline. We try to keep these differences same. Okay. So now how will we use this value to interpolate the mesh, the mesh of the physics object in the process frames? So we can use this value and use the lerp function. So suppose this is here the position will be p1, here it is position is p2. So we'll use p1 dot lerp. Lerp is basically interpolate p2 upon x upon y2. You can calculate this, implement this function yourself also, or Godot have also implementation. So you'll give a p3. Suppose it is giving a p3. So here position will be p3. Okay. Now let's see that implementation in the Godot. So this is our Godot scene. Our scene has a root node as by the name of character test scene, and the type of this node is node 3D. And then we have a light node, and also we have a world environment node, which is a default environment provided by Godot 4.2. And then we have this player node. The player doesn't have a body because it is an FPS game and it doesn't need a body. And because the user can't see what is the body is. And the player is of the node type is character body 3D, and the collision shape is of capsule shape. And then we have also a node for head, which is of area type. And then we have a marker 3D node by the name of camera mount. I will discuss the importance of it later. Then we have a camera node. The camera node is for looking into the scene. Then we have a node 3D type node with by the name of gun node, which is have the gun mesh as the child. The gun mesh is for now it is a cuboid shape. Then we have also a marker 3D node by the name of gun mesh mount. I will discuss the use of this also. Then we have the collision shape for the head, which is of spherical shape. You can see here. Then we have a bottom ray node, and it is for detecting if the player is standing on something or not. Because I didn't like the is on for function provided by this character body. Because for updating the is on floor function, we need to call move and slide, and I didn't like the move and slide function. And after that, the player node, we have also a level node. Uh, Not level a node, the name of the node is level, and the type is of node 3D. And then also we have three static bodies. One is ground, and the other two are this box one and box two. Okay. Then the player have a script also. The script have some already variables. The head node is for head, bottom ray is for bottom, and some already uh, decided variable for speed, gravity, jump velocity, friction, and max speed. And then also a variable for camera mount. And there are two variables: uh, camera mount previous global transform and camera mount current global transform. So I will discuss the importance of these variables later. And then we have a variable for camera also. Similarly, we have the variable for gun mesh mount. a variable for gun mesh mount previous global transform, and a variable gun mesh mount current global transform. This I will discuss the use of this later. And then we have a variable for gun mesh, and then we have a input function, and the input function is for moving the camera uh, of the player according to the mouse movement. Then we have the process function, and then phase process function. I will go inside the process function later. So in this phase process function, I am updating the variable name update every time it is called. I am making test true, and then we have the movement related code here. I will share this code with you all, no problem. And in the process function, these all are it doesn't matter. This part of the code doesn't matter because I use it for debugging and for the ease of testing the code. The important part is here. So I have added the comment. So if you want to test in on your device, you just have to comment this part like I have already commented, and then run it. Then after you have to uncomment this part and then again run. You will see the difference which this code makes. So I will uncomment this code. So this is the update variable. So uh, this is where I'm using the update variable. So when this update is true, it means the one phase frame has passed. So the previous transform is set to the current global transform for the mounts, and the current mount transform is set to the latest position provided by the camera mount. So what will be the camera mount? You can see here the camera mount is at the same transform as of uh, camera, because we'll be detaching this camera from this player node, and because we have to update this position of this camera and the transform of this camera in the process frames. So the this camera mount will be denoting the uh, these positions. If you see, suppose we are working on this process frame, then camera mount previous transform will be denoting the P1, and camera mount current transform will be denoting P2. Okay, so these are the two variables. Uh, same thing is for gun mesh mount also. Gun mesh mount is also having the same transform as of gun mesh. See here, this is the same as that of gun mesh mount. So now in the coming to the main part of the code. So this is the part where I am detaching the camera from the parent. This set as top level function does the same. So if you set this top level value as true, the node will not inherit transformation from this parents, and no transformation or only in global space. Okay, same thing I'm doing it for the gun mesh also. And now I talked about this part, right? Here it is. I'm setting the P3 as P1 dot ler P2, comma x1 comma y1. Okay, so this is the line where it is happening. So instead of ler function, I'm using this interpolate with, which is provided by Godot for this transform type variable. So this is the P1, which is the camera mount previous global transform, and this is the P2 for camera mount current global transform. And this is the variable x1 upon y1, which will give you the interpolation fraction. So same thing I'm doing with uh, camera and gun mesh. I will be sharing you this code, and you can try to run it in your desktop or machine.